recording. There we go. All right. And for our final one, this is on page 96. Here we have the fluorine atom. Does an atom need brackets? No, no brackets. How about our ion? The ion, yes, brackets. What type of brackets? Round brackets or square brackets? Round or square? Square. Okay, so we're going to draw that in here. Square bracket, square bracket. And do you remember, if we have a -1 charge, what is the most chemistry-y way of writing -1? Just writing negative. Okay? Negative means -1 or 1 minus. So if you just see a negative, that means 1 minus or -1. June, you found your book. Yay, good stuff. Okay, that's awesome. All right. So we've now learned that when we have an ion, we use square brackets and a charge. Let's go to that last question. Where do you think that anions get those extra electrons from? Where might they come from? I'm a little non-metal atom. I would like an electron. Your pencil is an electron. Got it. So if I'm a little atom, what's Brooklyn? Who has electrons? Another atom. So they get them from other atoms. So anions get their electrons from other atoms. Who might want to, what type of element wants to give away atoms? Or sorry, not atoms, give away electrons. Metals want to give away electrons. So those are the ones on the left-hand side of the periodic table. If you look up at that periodic table there, they are blue, okay? And they won't have, sorry. No. I know where most of the common things are, and I know like the atomic number of a lot of the common things. I know the mass of a lot of common things to 1 decimal place, but you know, I get confused. Iron and copper, their masses, one is 63.9, I think, and one is 65.4, and I don't know which one's which. You know what I mean? Yeah. Yeah. And when we get down into the boondocks of the lower rows, I'm like, I don't know what anything is. I mean, I know where everything in the first 2 columns are. I know where everything in the last 2 columns are. Beyond that, yeah. Yeah. Okay, so atoms that have only a few electrons, so that would be like less than half full. How many is full again? 8 is full. So how much is half full? 4. 4 is half full. So less than half full would be 3 or fewer electrons. Fewer needs an E, not fewer, fewer. So if you have 3 or fewer electrons in the valence shell, in the outer shell, Are they going to want to gain electrons or lose electrons? It's going to be easier to lose. So they're going to lose electrons in order to leave the valence shell empty, and our new outermost shell will then be full. So if we have, for example, here sodium, sodium has one valence electron. One valence electron. That means one electron in the outer shell. Its atomic number is 11, so it has 11 protons. That also means that a sodium atom has how many electrons? If it has 11 protons, an atom will have how many electrons? 11, because atoms are neutral, okay? Zero net charge, zero overall charge. And what happens with this little electron here? This little electron here goes bye-bye, out off into the universe. Probably it gets given to another atom, right? Like maybe it gives its electron to a nitrogen that needs one, okay? So that electron leaves, goes to another atom, and that leaves our valence shell empty, okay? So this is now empty. And that means our new outer shell is our new outer shell full or empty? It's now full. And what's so good about a full valence shell? Full valence shells are stable. Nature loves full valence shells because they are stable. I'm going to put or empty because they are stable. Is stable high potential energy? I'm going to let you finish writing first before I ask that question. Is stable high potential energy or low potential energy? Low potential energy. Are you guys okay if I just write PE for potential energy? Are we okay with that? All right. Now remember, nitrogen became nitride. Sulfur became sulfide. Fluorine became fluoride. When they became ions, their name ending changed to ide. What happened to sodium's name when it became an ion? Did it become sodide? Or did it just stay sodium? It just stays sodium. So if you have a compound, have you heard of sodium chloride? Yeah. Is it sodide chloride? Has anyone heard sodide chloride? No. Okay. Metals do not change their names. Non-metals change their names to ide. when they become ions, but metals just keep their regular name, okay? And because this is a positive ion, what do we call positive ions? Who has paws? Cats have paws. So what do we call positive ions? Cat ions, yes. So the name of a cation does not change. So metals don't change their names. You guys, you're being amazing. Don't take that as like reason to stop being amazing, but you're being amazing. And I'm so thankful. Okay. You guys were already amazing. So I did take it. Sorry. All right. So metals do not change their names. Because we lost an electron, we have one less electron. If we lost a negative, what charge did we become? Positive, okay? And because it was one less, it becomes +1. So let's write our symbol for sodium is Na. We haven't written the neutrons in the nucleus because sometimes we don't bother because it doesn't really matter. So I'm not going to bother with the mass number for this one. But what would we write for Na as the ion? What would we have to add to it? We would have to add a charge. And how would we write it? Just plus. You could write it as Na plus. You could write it as Na1 plus. You could write it as Na plus 1. This is the preferred method, but any of the others are okay. Any of the others are okay. Did we forget to do anything with our ion? Picture the Bohr model. We forgot the square brackets and the charge. So let's make sure we put on our square brackets. Like again, I said, I haven't left room for it, so I'm just going to stick it over top of things and between things. There's our square brackets. Doesn't make it look pretty, but normally we won't have writing on it. And the charge goes where? Does it go inside the brackets or outside the brackets? Outside, yes. Excellent. Okay. Now, what we're going to do with this one is we are going to do this one together because I want to show you how to do it when you have the atom. And this could go pretty quickly because we know there's 12 protons. And if this is an atom, how many electrons do we have if there are 12 protons? 12, yes. Net charge is 0. Symbol is Mg. That's a magnesium atom. In the magnesium ion, what's going to be different? Yes. Yes. Oh, because sometimes zeros look like O's. And so I tend to put a line through my 0 so it doesn't look like an O because O is for oxygen and it's a chemistry thing. Again, it's like why I write the L like that so it doesn't look like a 1. Do you know what I mean? They're kind of just idiosyncratic to me, just my own little funny things. Yeah. You don't have to write a line through the zero, okay? In order to get from the atom to the ion, what does that magnesium atom have to do? Is it going to gain electrons or lose electrons? It's got how many in its outer shell? 1, 2. If it's got 2, is it going to gain 6 to become 8, or is it going to lose 2 to become empty? It's going to lose 2, okay? So it is going to lose 2 electrons, lose 2 electrons. And how you can show that is you can just cross them out. You can be like, bye-bye. So if you're given an atom that is of the or a Bohr model of the atom, you can just cross out the ones that are in the atom, and that becomes the ion. What is the name? Is it magnide? Nope, it's just magnesium. Because that is a metal, and it is a, well, let's see, we still have 12 protons. How many electrons do we have now? We only have 10 electrons. That's positive 12, negative 10. What's our net charge? 2 positive. So the symbol will then be Mg, 2 positive. And you get to try the last one on your own. Okay, so everyone give that last one a go. So you can check the atom here, see if you got the same as I did. 13130Al, that's the atom. Is this one closer to full or closer to empty? Closer to empty, so we're going to get rid of 3. That means we have lost 3 electrons. What is the charge if we lost 3 negative things? 3 positive. And we can confirm that because we still have 13 protons. But now we only have 10 electrons, so we have positive 13 and negative 10, gives us positive 3. And what is the name of the aluminum ion? Just aluminum. Unless you're from anywhere other than Canada and the United States, in which case it is aluminium, because they actually have the extra I in there in every other country except for Canada and the US. Can't even say North America because in Mexico, apparently it is also aluminium. Apparently, so I've been told. Well, there is everywhere else in the world except for here. I know, it's crazy. What have we forgotten? I forgot it in the last example. What did I forget? Well, I forgot that, but what else did I forget on my Bohr model? 2 plus, and then square brackets, 3 plus, where do cations send all their extra electrons? Where do they send them? To other atoms, non-metals, yeah. So for example here, we've got these 2 atoms. We've got sodium and we've got chlorine. This is a sodium atom. And this is a chlorine atom. Sodium and chlorine. Sodium has, and we've only shown the valence electrons. We're not showing the inner shells. Okay, we're not showing the inner shells. Sodium has 1 electron and chlorine has one gap. So what can happen? Sodium can send its electron over to chlorine's gap, and you'll notice that that electron ended up right there. And now what we have is, instead of having sodium and chlorine, we have sodium chloride. So this is an element. Chlorine is an element. The combined elements are called a compound. Just a compound. They're just called a compound. And a compound is when you have two or more elements stuck together. Can you think why? Sorry, I'll wait until you finish writing. Can you think why this sodium ion and this chloride ion stick to each other? Why do they stick together? Because sodium has no electrons. What does that give sodium? It gave away an electron, so what happened to it? It became if it gives away a negative, it becomes positive. Yeah, and chloride becomes negative, and positive attracts negative. So we have this attraction between them. Now, what I've given you here is a bunch of practice drawing Bohr models. Okay? And you're going to start by drawing the Bohr model of the atom, just like we did here. Okay, we're going to start by drawing the Bohr model of the atom. And then we're going to draw the Bohr model of the ion, either by adding in electrons or by taking away electrons. On the sheet that you have, I'm just opening it up here. You get to first draw the Bohr model of the neutral atom. And you'll notice that you have up here a number at the top. That's the mass number. So that's going to let you figure out the number of neutrons. So you need to go find lithium. You need to find its protons, because it asks you to find the number of protons. It asks you to find the number of neutrons. And then in a neutral atom, what do you know about the electrons and protons in a neutral atom? Yeah, the electrons equal the protons. Yeah. Yeah. The neutrons is equal to the mass number minus the protons. All right, and then what you're going to do is you're going to redraw it as an ion, and you're going to put it in square brackets with the charge. Yes. Yep. 7 minus 3. Yes. So we would have 3 protons because it's atomic number 3. And then 7, the mass number minus 3, that gives us 4. And then we say, how many electrons do we have? Well, electrons is the same as protons. So that's going to be, how many electrons fills up the first shell? 2. So you're going to go 1, 2 right beside each other. And then 3. Then you're going to redraw it as an ion. You still have 3 protons. You still have 4 neutrons. Those don't change. Do we get rid of an electron or do we add 7? We get rid of 1, so we're just going to redraw it here. And then we need square brackets. And if you've forgotten, shell number 1 needs 2, shell number 2 needs 8, and shell number 3 needs 8. And we would put our charge up at the top. All right, I'm going to let you guys practice. I'll come around and let you and help you out if you need help. So will Abby. Okay? Hi. Yeah. Yes. I don't. Actually, right on my desk. Actually, no, you can just look at it. Does anybody else need a periodic table? By the way, if you need a calculator, there are some on the front desk, just underneath the front periodic table of elements. Yes. But mine are like, that goes to, and then H and T. First one. Okay, yeah, that one's a good one. Oh, like plus two others. Okay, so there's two ways to do it. Two different tokens of which one first and this is I can keep one of them. Second year. Second year also say I have non-positive and one and now I'm going to 5, 6, 7. So this one, we've got rid of the negative, use the negative and the positive, yeah. I. Okay, so, 12 1, 2. Why are there so many Technically, we don't ever put more than two in here because it just Bohr all breaks down at that point. They actually have to eat two. So it's 17. That 19 is the number of really rare. That's your neutral activity. But over here, instead of putting one more, and we don't want a partially full shell. We don't want a shell that's solidly full. Yes, very nice. Yes. Yes, yes. Very nice. Okay, and I'll put it all in here. Oh, actually, your back. Your things. Because yeah, if you're studying,
I take it next.
Yeah.
I need a job and well.
Yes.
Yeah.
So folks, you're not handing this in. No. It's just what we did today. Similar. Okay, but so, ladies and gentlemen, next week, you're going to have a quiz on drawing Bohr models of atoms and ions. It's going to be very similar compared to what we did today, okay? But you would need to be able to read, oops, what did I do wrong? What did I do wrong? I put the mass number on the bottom and the atomic number on the top. You should know how to read that and figure out the neutrons. Okay? All of the teachers that we that are hello. Guess what my battery is right now, actually.
Hmm?
On my phone.
Huh?
Guess what my battery is on my phone right now.
What?
67.
Really?
Yes.
Is it?
Yes. So I can't sit here without the cover.
Have you worked with a phone with 0% battery? It's so cool. So you just need to like finish up everything you're doing so that
Yeah.
you die.
So I work on it. Now, so for some reason, live on 0% battery. Oh, is that us? No, we are not turning Bohr mode. Is that us? Things to think. Yeah. Because I'm Chinese. Okay, well, it's like watching them both. It's not Korean. Number one. Was that the trail? Oh, look, yeah, I got found out. You can see, I was here one day. Oh, he was like trying to be like, I never thought, I never believed the one time he was a prank. Right. That was so fun. I love just random people like dating. Yeah, no, yeah. I thought you and last year. You did last year? No, it's right. Oh. Like culturally forward playlist. Like history. Yeah, because on Tuesday, I do. Yeah, Tuesday, the day we come back. What the fuck? It's my birthday. That's not fucking funny. That's not. What if instead of Spence had his bench, and instead of her being really nice, hated all of her time. One more day, and she gets 1,000 lashes. I wasn't. Okay, bye.
Yeah,
I'm losing most of my head. No, I'm serious. What exactly is this? How long can you stay awake?
yeah.
Like, what happened?
Try it. I tried it.
Tuesday, April 7th.
Go, Chance.
4.2.
Go, go. Oh,
I like that.
where is it?
It said Tuesday, April 7th, 4.2.
You must change this one. Go, 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 go. Go.
Math is your turn now. I didn't die.
Keep going.
I gave that to
This is fun. They need to talk you out. Hey. Or I will. You know what? Hello.
It's active. It's active.
No, it's not.
You're so rude.
Yeah, it's exactly active. Why you like that?
Why are you so rude after me?
It's active.
Is that first today? That was where.
No.
Yeah.
What is that?
Only up until noon.
No, Miss Vance, it's a quiz on 4.1 and 4.2. And we have a quiz on Wednesday.
So everything.
Wednesday, so usually
That one is harder.
Page 96. I think. Let's see if I'm right. I have to record.
I think that's where it came from.
Oh, no. Page 43. I'm totally wrong. I think 96 was what my 9s were on. Okay. Page 43. Whoops.
I have to go take my spot.
And I need to get this recording. Oh, I need to stop